Hello everyone. I'm going to take a look at the altitudes of a triangle and the point of concurrency called the orthocenter. So first, an altitude is basically the height of a triangle. This is the segment that goes from a vertex and is perpendicular to the opposite side. So let's just start with an example of an altitude. So I'll start with just a triangle. And maybe we'll call this triangle ABC. So the altitude of this triangle is going to go from one of the vertices, and then it's going to be perpendicular to that opposite side. So if I drop this straight down, make the right angle here, this is going to be an altitude. So I would say that this is the altitude from point B to the segment AC. Okay. For a lot of triangles, the altitude, the height of the triangle is on the inside. But if we have an obtuse triangle, that altitude can also be on the outside of the triangle. So just drawing this triangle here. Now I have an obtuse triangle. And if I want to draw the altitude from B to AC again, I need to make sure that it's a right angle. So what we think about is if I take this side length AC and I extend it out, so this isn't part of the actual triangle, but that's the line that contains the side of the triangle. Now I can drop the altitude straight down from B, make the right angle, and that is the same idea. It's the altitude from B to the side, the line that contains AC. Okay? I can draw the altitudes from the other vertices as well. So a triangle has 3 vertices, so it has 3 altitudes. The altitudes are concurrent, meaning they all intersect at the same point. They are concurrent at the orthocenter. So there are 3 different possibilities for our orthocenter. If we have an acute triangle, our orthocenter is going to be on the inside of the triangle. So we'll start with an acute triangle here. And if I draw in my altitudes, so from each vertex, dropping straight down perpendicular to the other side. Here we'll go straight over, making a right angle there. And then our last one, right angle like that. So then that point of intersection on the inside of the triangle, that is the orthocenter. So I'll make a little note. So the orthocenter is inside. The second option is if we have a right triangle, and in this case, 2 of the altitudes of the triangle actually are sides of this triangle. So we already have the right angle here, so from this vertex, if I try to drop in the altitude, it's actually just this side of the triangle. And the same thing going with this side here. The third one is we go from this vertex, making a right angle on the hypotenuse of the triangle. But our orthocenter is on the triangle. It's on the right angle. So that is our orthocenter. So the orthocenter is on the triangle. Okay? And the last option is if we have an obtuse triangle, and in this case our orthocenter is actually going to end up on the outside of the triangle. So as we saw up here, when I have an obtuse angle, when I try to draw on that altitude, the entire altitude is outside of the triangle. So that means where the altitudes intersect is also going to be outside the triangle. So I'm going to start with obtuse triangle. Okay, and as we discussed up above, I'm going to think about extending the sides of the triangle so I know where that right angle is going to be. So here, dropping this straight down, making a right angle with that side, I'm actually going to extend it a little bit further, but that's the line that contains the altitude. We do the same thing. I'm going to extend this side of the triangle so that I can drop perpendicular, make that right angle here. So there's a right angle like so. Again, so that's just extending out. That's the line that contains the altitude. And then our last one going through this vertex, and then now we're going to be perpendicular to this last side of the triangle. So, and then concurrent with the other ones, so something like this. So we got right angle here. So in this obtuse triangle, one of the altitudes actually is inside, but the other two altitudes are outside the triangle. So now we have this point of intersection. Our orthocenter here is outside. So those are the three possibilities for the orthocenter. And the orthocenter is the intersection of the altitudes of a triangle. Besides that, there are no special properties about the orthocenter other than it is concurrent from the altitudes.